So if you watched the last video, you know now how to calculate this on your TI 83 or 84. We're looking for the area between these two fixed boundaries. So we know that we're going to use normal CDF, right? We're going to use a lower bound of negative 1.2, an upper bound of 1.35, and since we're working with the standard normal, a mean of 0 and a standard deviation of 1. And if you execute that, you're going to get 0.7964. Whoops. And that's a decimal place right there. If you try to execute that and you get a syntax error, be aware what probably happened was you probably used the subtraction key rather than the actual negative key, so make sure you don't do that, okay? But the reason I'm putting this video together for you is because I wanted to talk to you, it's not really covered in the other video, what happens if you're doing a one-sided interval? So you got to remember, right? Technically, this curve goes on forever. It's asymptotic to the x-axis, right? So you need really to find the area from 1.35 to infinity, right? And it's technically the area under which you need to find. So the way that I enter something like this in my calculator is basically I just use a really big number. So I'm going to use 1, and you've got this exponential key on there, and I'm going to say 1e to the 99. And that essentially means 1 times 10 to the 99th. So I'm going to use 1.35 as my lower bound, and then I'm going to use this 1 times 10 to the 99th as my upper bound. And if you execute that, you're going to get 0.0885. And so once again, this capital E thing here, talking about this guy right there, I get that by doing the second key and then the comma key, and that will pull up that E, that exponential E, okay? So if you had a left-sided interval, you could use negative 1 e to the 99, right? If you had a left-sided interval, you could use that as negative infinity. So that's how we do one-sided intervals.